Hey guys, it's me, Carla, again, and today we're going to be talking about the heart again. So before we get started on the pathophysiology side, as the title so nicely states, I want to refresh our memory on the physiology side. So physiology would just be normal heart function. Now, the pathophysiology of mitral regurgitation is going to be how the leak occurs, which is what mitral regurgitation is, and the effects that it has on the body. Now, whenever we're looking at this, we are actually going to focus on the left side of the heart, where the oxygenated blood will enter the left atrium and flows through the left ventricle. Now, the mitral valve's job in between is going to be to close tightly when the left ventricle contracts to push blood forward into the aorta, ensuring no backflow, similar to what we discussed in the last video. What I just described is actually what a heart's supposed to do, right? It's supposed to go through the mitral valve, then go through again, mitral valve again, and then boom, presto, good to go. But what is MR? What is mitral regurgitation? It's going to be the leakage or backward flow of blood from that left ventricle back into the left atrium when the heart contracts. In other words, it doesn't all get pushed through, which is no bueno, or not good. So how does this happen? Well, it can result from damage to the valve leaflets or the structures that support them, like coronary artery disease, infection, or chronic hypertension. If we look at this diagram here, what it's showing is a healthy versus a leaky valve. When it's a healthy one, it's going to constrict tightly. It's not going to let anything through. But with the leaky valve, it's going to come through, which in turn causes it to work way harder, which we'll talk a little bit more about that here shortly. But I'd also like to touch base on this diagram here, which is going to show you exactly what I discussed earlier, which is going to be it coming in, going through, it coming out, and going back into the body. So what happens? What happens when that blood comes back instead of going all the way through? Well, it leads to volume overload. Both the left atrium and the left ventricle are forced to handle an excessive volume of blood. The left ventricle must pump the same volume of blood twice. And that leads to dilation and failure. To cope, the chambers will stretch and dilate and eventually weaken, leading to blood backing up into the lungs, which leads to some symptoms we will discuss later. All right, so symptoms. When we have the symptoms that you would expect are going to be shortness of breath. Like I mentioned, the blood backing up into the lungs will cause that shortness of breath. You'll also experience fatigue. You can get swollen legs. And then you can also experience heart palpitations. Also mentioned on this diagram are going to be the prognosis, okay? And this is going to really make a difference. If we have a mild case of MR, we are going to generally be okay, right? We're going to have some monitoring. It can be adjusted, we'll be fine, okay? But if it's going to be severe and chronic, that will lead to heart failure, which we can refer back to what was mentioned earlier about the stretching causing too many issues, and then ultimately the heart failure that follows because of it. We fix it. Good question. So treatments can include two things, right? We can do medications, right? And that's great, but it doesn't really fix, it just manages the problem. The only way to really fix the problem is going to be surgery, and then we would either replace it or we would do a repair. But that is going to be the only way that we can actually fix the problem. Why is the pathophysiology so important? Well, understanding the pathophysiology of mitral regurgitation, which is the failure of that one-way door not working, explains why a small mechanical issue can lead to such severe systemic symptoms. Now, if you're experiencing any of these symptoms, I hope you've gone to see your doctor, because it's important. It's important to take care of your heart because we need it to survive, right? Now, all my information is going to be cited at the end, and I hope that this makes a little bit of sense, or that you have a little bit better of an understanding on the concept of mitral regurgitation, the pathophysiology side of it, and even a little bit of the physiology, which we discussed in our previous video. All right, I hope you have a great day. Thank you.